All right, so you've got the basics of PostgreSQL down pat, but maybe your app is starting to feel a little sluggish. Hey, that's actually a great problem to have, right? It means you're growing. Today, we're going to go way beyond the simple select statement and unlock 5 database superpowers that'll make your application absolutely fly again.
So your app is a hit. First off, congratulations. Seriously, that's awesome. But with all that success comes more data, more users, and suddenly, those queries that used to be instant now feel like they're crawling through mud. This isn't a failure, you know? It's a classic growing pain, and it just means your database is ready to level up. And don't worry, the solution isn't just to throw more expensive hardware at the problem. Nope, we're going to work smarter. We're going to explore 5 advanced techniques to make your Postgres instance faster, way more efficient, and ready for whatever scale you can dream of.
Okay, our first power-up is all about indexing. Now, you probably use basic indexes already, which is fantastic, but to truly supercharge your queries, we need to get a little more strategic, a little more clever. These advanced techniques can give you some massive performance wins.
First up to bat, the partial index. I love this one. Think of it like a VIP list for your data. Instead of indexing every single row in a huge table, a partial index only cares about the rows that meet a specific condition. You know, the ones you're actually querying all the time. It's all about precision over brute force.
Here's a perfect example. Imagine you're constantly looking up orders with a pending status. A normal index on that status column would be huge and bloated with all the shipped, completed, and returned orders you hardly ever search for. The partial index, on the other hand, it's tiny and lightning fast because it only contains the pending orders. It's a total game changer for efficiency.
Next up in our bag of tricks is the covering index. You can think of this as the ultimate query shortcut. See, it doesn't just store the column you're searching on, it actually includes all the other columns your query needs to return. It becomes a genuine one-stop shop, giving the database the answer without any extra work.
The real magic of a covering index is that it lets Postgres answer the entire query from the index alone. Normally, the database uses an index to find the right rows, but then it has to take a slow trip back to the main table to grab the rest of the data. By including everything you need right there in the index, you completely skip that second step. This creates something called an index-only scan, and it is incredibly fast.
Finally, for those truly gigantic tables, I'm talking billions of rows, like log data, we have a special tool, the BRIN index. A standard B-tree index on a table this big would be enormous itself. A BRIN index, however, is super tiny. It works by storing just the minimum and maximum values for huge chunks of the table, which makes it absolutely perfect for time series data where you're often querying for a specific range of dates. Okay, let's move on to our next power-up. This one is all about the code itself, because performance isn't just about infrastructure, it's also about writing elegant, readable, and super efficient SQL.
Ah, man, I think we've all been there, right? Staring at a query that looks like a Russian nesting doll of confusing nested subqueries. They're a nightmare to read, and they're even worse to try and debug when something, inevitably, goes wrong.
Well, the solution is the Common Table Expression, or CTE. Instead of that messy nest, a CTE lets you define these temporary, named result sets using a with clause. It breaks your logic into clean, readable steps. It basically transforms your query into a story. First we do this, then we do that, making it just infinitely easier for you or anyone else to understand and maintain.
Now for one of my absolute favorite features, window functions. So unlike a normal aggregate function like sum, which just squashes a ton of rows down into one single number, a window function performs a calculation for every single row based on a window of related rows. You get the detail and the big picture aggregate at the exact same time.
A running total is the perfect use case here. The real magic is that over clause. It tells the database, hey, for this row, calculate a value, like a cumulative sum, based on a window of other rows, like say all the sales that came before it. This is so powerful for building things like dashboards and financial reports in a single clean query. All right, let's zoom out from the SQL code for a second and look at the bigger picture. Our third power-up is about mastering the whole environment your database lives in. And specifically, we're talking about connections and routine maintenance. So this right here is a classic performance killer. Without something called a connection pooler, every single request from your app forces the database to create a brand new connection from scratch. That whole process is surprisingly expensive, and when you're at scale, that overhead can bring your entire system to its knees. The solution is a connection pooler, like the popular tool PGB Bouncer. It basically acts like a traffic cop, or maybe a switchboard operator. It maintains a whole set of ready-to-use connections. Your app connects to the pooler, which is instant, and just gets handed a warm connection. This one simple change can let you handle thousands of clients with ease, and it dramatically reduces resource usage.
Next up, let's talk a little bit about housekeeping. See, when you update or delete rows in Postgres, the old versions are kind of left behind as dead rows. The vacuum process is the cleanup crew that comes by and gets rid of them. But for tables with a ton of writes, the default cleanup schedule just might not be aggressive enough, which leads to this performance-killing bloat. You can actually tune the scale factor on a per-table basis to make that cleanup happen way more often.
Okay, time for our fourth power-up. And this one is for when your data grows to a truly massive scale. We're talking about tables that are hundreds of gigabytes, maybe even terabytes in size. It's time to tame the giants.
The ultimate technique for this kind of challenge is table partitioning. The concept is actually really simple, but it's incredibly powerful. You take one giant logical table and, behind the scenes, you split it into many smaller, much more manageable physical tables, usually based on something like a date range.
The process is pretty straightforward. First, you create a parent table, and you declare how it's going to be partitioned, usually by a date range. Second, you create the child tables, one for August, one for September, and so on. Now, here's the best part. You still just query the main parent table like you always did, but Postgres is smart enough to scan only the relevant little tables. This partition pruning can make your queries on huge datasets orders of magnitude faster.
And there you have it. We have covered a lot of ground, from fine-tuning individual queries all the way up to architecting for massive scale. Let's do a quick recap of your new professional-level skills. You're basically a database pro now.
You've just unlocked a seriously powerful new toolkit. You now know how to go beyond basic queries with precision indexing and elegant SQL. You can master your environment with smart connection management and proactive maintenance. And you have the ultimate tool, partitioning, to tame even the absolute largest datasets. You are now equipped to build applications that can truly scale.
So now, with performance no longer holding you back, the real question is, what are you going to build? What new features can you dream up now that you know your database can handle the load? That's the really exciting part. Thanks for joining this explainer, and happy coding.